Hello everybody, I'm Nicole Christensen, and this video is about how aspects of mechanical engineering can help establish a more reliable and cost-effective source of energy in the Arctic. More specifically, this video will talk about how wind turbines can be designed by mechanical engineers to survive the harsh weather conditions of the Arctic. So what do we know about the Arctic? Well, we know that it has an extremely harsh climate that includes a temperature range of -34 degrees Celsius to 12 degrees Celsius and an average wind speed of about 40 kilometers per hour. These weather conditions cause many problems that are unique to the Arctic region. For example, a reliable energy source is needed to develop any region. But because of the harsh conditions, establishing a reliable and feasible energy source in the Arctic has proven to be difficult. Some areas have already started using wind turbines. For example, the Yukon runs on about 50% of wind power. But in areas such as Alaska and the Northwest Territories, fossil fuels still take up a huge majority of energy generation. The most popular sources of power in the Arctic region are diesel generators. Unfortunately, the low temperatures cause these generators to be unreliable. Also, since fossil fuels are non-renewable, importing fuels so far up north is a high and constant expense. An alternative source of energy that will lower the costs and environmental effects of diesel-powered energy sources are wind turbines. Wind energy is renewable, so there isn't a constant expense of importing resources, and there are no greenhouse gas emissions. Also, wind turbines are a good fit for the harsh climate of the Arctic because there are such high wind speeds. This makes wind energy a feasible alternative in this region. However, in order for wind energy to be reliable and efficient in this region, the turbines need to be specifically designed for the harsh conditions. This is where aspects of mechanical engineering can be used to establish a reliable energy source in the Arctic. Wind turbines have many moving parts, and all of these moving parts need to be specially crafted by mechanical engineers to survive and be efficient in low temperatures. Three examples of parts that mechanical engineers can manipulate in this model are bearing configuration and lubrication systems, mounting systems, and the blades. First, let's talk about the bearing configuration. Many tests have been done in a temperature-controlled freezer to find the optimal bearing configuration at low temperatures. For example, parameters for the torque applied and the geometric dimensions are determined by this process. Obtaining these optimal parameters increases the durability and minimizes the decrease of efficiency of operating in such low temperatures. Another part of the bearing system that can be manipulated by mechanical engineers for optimal performance is the bearing lubrication. Finding lubrication that is effective in such a high range of temperatures has proven to be difficult. The lubrication needs to have a high resistance to change in viscosity and a very low freezing point. Luckily, mechanical engineers have ran tests to find the optimal lubrication. Moving on, mechanical engineers also need to analyze the mounting systems. Possible issues involving resonant frequencies, material stiffening, fatigue correlations, brittleness, and ultimate strength need to be taken care of in order to have a reliable energy source. Lastly, mechanical engineers can optimize the geometric dimensions of the blades. The temperature-controlled freezer can be used once again to maximize the durability and performance of the blades on the wind turbine. To summarize, further developing the Arctic has many unique challenges because of its harsh climate. One issue is establishing a reliable and efficient energy source. The use of fossil fuels should be reduced by using wind turbines. Aspects of mechanical engineering can be used in the design of the wind turbines to make them a reliable, cost-effective source. Well, that's the end of my video. I hope you enjoyed it and learned something about wind turbines in the Arctic. Thanks for watching.